Welcome to lesson 4.2. We're going to look at trigonometric functions, specifically using the unit circle. So we mentioned the unit circle in 4.1. We're going to look at that specifically in this lesson. A lot of objectives. So we're going to hit a bunch of things in this lesson. We're going to use a unit circle to define trigonometric functions of real numbers. We're going to recognize domain and range for sine and cosine. We'll first talk about what sine and cosine are. We're going to find exact values of the trigonometric functions at pi over 4. So we're going to calculate it exactly, and then from there, moving forward, we're just going to use what we get. But I'm going to show you how, where that comes from. But it's not something you're going to have to do every time. We're going to talk about even and odd functions. We're going to recognize and use fundamental identities. We're going to use periodic properties. We're going to evaluate trigonometric functions with a calculator. So there's a lot that we're going to touch on in this lesson that we're going to expand on later. First thing is a unit circle is a circle of radius 1 with the center at the origin. So coordinate plane, middle of the circle, center of the circle is at the origin. The radius of this circle is 1 unit. The equation of the circle is x squared plus y squared equals 1. And that's what it would look like. So again, you've got origin, center of the circle is at the origin. Radius, which obviously means all the way around, is 1. Okay. In a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. So this angle here is going to directly relate to the length of the arc out there because the radius is 1. There are 6 trigonometric functions that we're going to talk about. These are the names, if you were to say them out loud, these are the abbreviations that you're going to see. So right off the bat, SIN, you're not going to pronounce that sin. It is sine, all right? Cosine, tangent, cosecant, secant, and cotangent. Oops, sorry. So when you're thinking about, hold on. I don't know if I got it right. Yeah, I'm going to write this. Nope. There we go. Okay, so you got your unit circle, right? Bad drawing, but you get the idea. So let's say you have a point here. That point has an ordered pair, right? Well, that's what these things are going to be. So if this is point T, for instance, or if this is angle T, same idea. Whatever is the y value is the sine. Whatever is the x value is the cosine. So you would say, what is the sine of angle T? And the answer would be the y coordinate of the point that's out there. What is the cosine of this angle T? It's the x coordinate of the point that's out there. All the other 4 trigonometric functions are based off of that ordered pair. So tangent is the y value divided by the x value. So whatever that number is, divided by whatever that number is. Cosecant is just the reciprocal of whatever sine is. Secant is just the reciprocal of whatever cosine is. Cotangent, you can think of in 2 ways. It's x divided by y, or you can think about it as the reciprocal of tangent. The reason why these are listed in this way is because you want to pair up in your mind these. Sine goes with cosecant because cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. So that's a pair. Tangent and cotangent, that's a pair. It's probably pretty easy to remember that like tangent and cotangent go together, right? The hard one is remembering which of the secant or cosecant goes with the sine or the cosine. When I first learned this, I got that mixed up. Someone pointed out to me um, a way to remember, which is each pair has a co, right? So cosecant has to go with sine, and secant goes with cosine because each pair has one co. Uh, that doesn't mean anything other than it's a way to remember it, right? And then even that even works when you apply it to the tangent and cotangent. Each pair has one co. All right, let's get rid of that writing. Okay, so use the figure to find the values of the trigonometric functions at t. Right, so you got angle t, arc t. That point is root 3 over 2 for the x value, 1/2 for the y value. All right, so that means the sine is the y value. So the sine of t is 1/2. The cosine of t is the x value, so root 3 over 2. Tangent is just 1/2. It's y over x, right? So it's 1/2 divided by root 3 over 2. So when you simplify that, you end up getting 1 over root 3. Rationalizing it, you get root 3 over 3. All right. Cosecant is just the reciprocal of whatever y was. Well, y was 1/2, so 1 over 1/2 is 2. Secant is the reciprocal of x. X is root 3 over 2, so it's 1 divided by root 3 over 2. Simplify, you get 2 over root 3. Rationalize, you get 2 root 3 over 3. Sorry. Cotangent is x over y. So again, there's two ways you could do this. You got to take the reciprocal of what tangent was on the last slide, or you do x over y. Root 3 over 2 divided by 1/2 simplifies to root 3. No rationalizing needed there. So what I want you to get out of that is if you know the x and the y, so the cosine and the sine of any function, of any point on the unit circle, you can translate that to all the other trigonometric functions. Same deal here. So let's draw our unit circle. Okay, good enough. Remember from lesson 4.1, what does it mean for the angle to be pi over 2? Remember, it's 2 pi all the way around, right? So half a pi is going to get you to right here. Well, what's the ordered pair there? The ones in between, we're going to need to do some more work to understand what each of those ordered pairs are and why they are what they are. However, if you know the things that we've already defined, circle, origin is the center, the radius is 1, you know that this distance is 1, right? You also know that so that means the y value would be 1 there, right? You also know that the x value, since it is right above the origin, must be 0. So the ordered pair here must be 0, 1. Well, let's find all the trigonometric values there. Sine of pi over 2 is just the y value there, right? So it's 1. Cosine of pi over 2 is the x value. So in this case, it's 0. Let's do tangent. It's y over x. So it's 1 over 0. Cannot divide by 0, even in trigonometry, so it's undefined. Cosecant of pi over 2 is the reciprocal of sine. So it's 1 over 1, which is 1. Secant is the reciprocal of cosine. So it would be then 1 over 0, which is undefined. Last one is cotangent. Two ways to look at it. It's either x over y, which in this case x is 0. Oh, I'm hitting the wrong button. X is 0, y is 1, so it'd be 0. So those would be all the trigonometric functions at pi over 2. Why don't you pause this, give it a try for pi. Remember where pi is, right? If the full revolution is 2 pi, half the revolution is at pi. So consider what that ordered pair is, and then just apply those x and y values into those 6 trigonometric functions. So why don't you give that a try? We'll pause it, give it a try, and then come back and check. I'll have the whole thing worked out, and then we can compare. So the first thing you need to figure out is what's the ordered pair at pi, and that ordered pair would be negative 1, 0. Remember, you went from the origin left 1, and then you didn't go up or down at all. So negative 1, 0. Sine is the y value, which is 0. Cosine is the x value, which is negative 1. Tangent is y over x, so 0 divided by negative 1 is 0. Cosecant is the reciprocal of x, or sine, so it's 1 over 0, so undefined. Secant is the reciprocal of um, of x. I think I said cosecant was the reciprocal of x. That cosecant is the reciprocal of y. Secant is the reciprocal of x. In this case, 0 over negative 1, which is 0. Cotangent is x over y. Negative 1 divided by 0 is undefined. Okay, let's take a look at the next one. So find the coordinates corresponding to all special angles between 0 and 2 pi. So this is the full unit circle. What I would do is maybe screenshot this slide, save it so that you can always refer back to it as you're working. You can easily Google just Google unit circle. You can get nice versions of this, print it out, whatever, have something like this available to you as you're working through everything in this chapter. So as you can see, the two places that we just worked out, well, root 3 over 2, 1/2 was one of the ones that we just worked with. In an example, we just did pi over 2, which is that 0, 1. We have negative 1, 0 is at pi, and that's what we worked out there. So these ordered pairs all the way around are cosine and sine of every special angle. The reason why these are special is because these are the ones that work out. Anything in between these special angles are all things that are going to be irrational. Things we can still calculate. That's actually the last part of the objective, is looking at how to do that on the calculator. But these are the ones that you're going to need to know. The inside of the circle represents all the radians, and that's something that we worked out in the previous lesson. These all are the x and y, or the cosine and sine of each of those points. So again, this is something to have on hand. All right. So, well, let me go back a second here. All right. The next part of the objective is specifically talking about this spot right here. So in future lessons, we're going to look at 30 degrees and 60 degrees. But why? Why is this root 2 over 2 and root 2 over 2 for the cosine and sine of pi over 4? What we're going to do is we're going to prove that that is true. So again, what we're about to do, and I was mentioning this when we were going over the objective at the beginning, this is not something you're going to have to do every time. This is not something you're going to have to really do any time again. It's just, I'm going to show you why those numbers are those numbers. We will be looking at these and these in a future lesson. What's of note here is once we understand where these numbers come from, look at the sine and cosine for those other angles, they translate, right? So the 45-degree angle here, 135 is just the 90 plus 45. So it's the equivalent angle on that spot. Down here, you've got 225. That's just 45 plus the 180 here, right? And then this one here is 315. That's just 270 plus 45. So these are what are considered your 45-degree angles. Notice the sine and cosine for them. All the same absolute values. It just depends what quadrant you're in, whether or not the root 2 over 2 is positive or negative, right? So in quadrant 1, both are positive. In quadrant 2, sine is negative, cosine is positive, right? X is negative, y is positive. Down here in quadrant 3, they're both negative, right? But think about points on a coordinate plane here. That's what it would be for x and y. Both the x and the y down here are negative. So that's why the sine and cosine are. Quadrant 4, x is positive, so cosine is positive. Y is negative, so sine is negative. So anyway, that's what we're going to be looking at here is just like, why are these numbers what these numbers are? Why are they both root 2 over 2? So that's what we're going to talk about in the next part of the objective here. So trigonometric functions at t equals pi over 4 occur frequently. Those are the ones we just pointed out on the unit circle. We use the unit circle to find values of the trigonometric functions at t equals pi over 4. We see that point P, which has a and b. So we're going to prove why a and b are both root 2 over 2. Lies on the line y equals x. Thus, point P has equal x and y coordinates. So in order to do what we're about to do, we had to prove that y equals x, right? If you drew the line y equals x through the circle, you're going to get to that exact angle of pi over 4. Think about what a 45-degree angle means, right? Because we just looked at that in the unit circle. This is where pi over 4 is where the degree is 45 degrees. 45 degrees is half of 90 degrees. So this is cutting this quadrant directly in half. And we know that A and B have to be the same because the x and y have to be the same on that spot because it's on the line y equals x. All right, so we're going to use that fact as we prove this. All right, so you start with x squared plus y squared equals 1. That's the equation of the unit circle, right? Point P, which has the ordered pair A, B, lies on the unit circle. So we could have used any ordered pair there, but specifically since we're talking about that picture we just had, the x is A, the y is B. What we just talked about where the A and the B have to be equal, we're just going to substitute A for B. All right, so we can then say A squared plus A squared equals 1. We can combine those like terms. A squared plus A squared is 2A squared. Divide by 2. A squared equals 1/2. Take a square root, and you get square root of 1/2. We're only looking at, I know when we solve equations, we think about it as plus or minus, but A has to be positive, right? The A value can't be negative. So we're only going to be looking at the positive version there. And then one extra step, if I have square root of 1/2, you can take a square root of both. Square root of 1 is just 1, and you got root 2. We need to rationalize. And what you end up with, 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. So a is root 2 over 2. We already talked about how a and b are the same. So that's why, hold on. That's why a and b are now both root 2 over 2. So that's why they are, right? And then again, what I was showing you before, that means for 135 degrees, it's the same numbers. It's just you make the first one negative, the second one positive. It's the same numbers down here. They're just both negative. It's the same numbers right here. It just goes positive, negative. Then once we know that x is root 2 over 2 and y is root 2 over 2, we can find the other 4 functions. So what is cosecant of pi over 4? Well, cosecant is the reciprocal of sine. Sine is root 2 over 2, so it's 1 over root 2 over 2. All right, simplify, you get 2 over root 2. Rationalize, you get 2 root 2 over 2. 2's cancel, and you just get square root of 2. All right, secant, well, since sine and cosine are the same, cosecant and secant are going to be the same, so you're going to end up with the same exact number there. Cotangent, well, if x is root 2 over 2 and y is root 2 over 2, anything divided by itself is 1. So pretty simple there. And then tangent would have been the same. Tangent would also be 1. The domain of the sine function and the cosine function is all real numbers. The range has to be between -1 and 1. So that means you can go forever on these sine functions. They can keep going forever. So the x is any number you want. But the y value will never be anything more than 1 or anything less than -1. And the reason for that is, when you think about what we were talking about last lesson, you can go around this circle as many times as you want. And that's what we're talking about with the domain. You can go the other direction as many times as you want. You can go in the negative direction as many times as you want around that circle. You're always going to land somewhere on the circle, no matter how many times you go around, right? Once you just pass go, it's like Monopoly, right? Once you pass go, well, I guess you don't collect $200, whatever. You get what I mean? You just keep going around the board, right? You can go around the board as many times as you want until someone runs out of money, or until everyone runs out of money but you. But you can't, in this case, on the circle, you're always going to end up somewhere on the circle, just like you're always going to end up somewhere on the Monopoly board. That place on the circle can't, the y value is never going to be more than 1, right? It's never going to be less than -1. Right, using what we know about even and odd functions. The test is when you substitute in -x, or in this case, -t. For cosine and secant, when you substitute in -t, you just get back to positive. So cosine and secant are considered even. When you substitute in -t for the other 4, you get negative, like the entire thing becomes the opposite. So those would be situations where those functions are considered odd. So find the value of each trigonometric function. Secant, since secant is one of the ones that is considered odd, if you have a negative, it becomes positive. I'm sorry, it's even because when you have negative, it becomes positive. So secant of -pi over 4 is the same thing as secant of pi over 4. And we just define secant of pi over 4 as root 2. So once we define these, and once we're able to use the unit circle, you'll just essentially you're going to have these memorized, or you're referencing the unit circle. But then that would just be square root of 2. Sine of negative pi over 4 becomes the opposite of sine over pi over 4. Sine of pi over 4 is root 2 over 2. So then the opposite of that would be negative root 2 over 2. All right, so you have some fundamental identities. Sine and cosecant are reciprocals of each other's. And these are all reciprocal identities. Cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocals of each other. And then the quotient identities, these are basically the ones we've already talked about, but tangent is sine over cosine. Cotangent is cosine over sine. Easy way to remember that, like which one's which. Tan and sine, so no cotangent and cosine. Cosine's on top for cotangent. And then reciprocal identities, which we just kind of talked about. Sine is equal to 1 over cosine. Cosecant is 1 over sine. Sine gerene over cosine gerene is equal to tan gerene. Okay. All right, so using quotient and reciprocal identities. Sine of t and cosine of t are equal to those things. So sine of t is 2/3, cosine of t is root 5 over 3. Find the value of each of the 4 remaining trigonometric functions. If you know those two, if you know sine and cosine, you can figure out the other ones, right? Because tangent is just whatever sine is, 2/3, divided by whatever cosine is, root 5 over 3. So simplified, ends up just multiplying by reciprocal. You end up with 2 over root 5. Rationalize root 5 over root 5, and you get 2 root 5 over 5. Cosecant is just 1 over sine, so it's really just the reciprocal of 2/3, which is 3/2. Secant is the reciprocal of cosine, so you end up with 3 over root 5. So again, just reciprocal of root 5 over 3. Rationalize by root 5 over root 5, and you get 3 root 5 over 5. Cotangent is 1 over tangent. So we already figured out tangent on the last slide, so it's just a reciprocal of that. You could also do it as cosine over sine. Same thing, you're going to get the same thing. You're going to need to rationalize, and you end up with root 5 over 2. So given, same thing. So given sine of t is 2/5, and cosine of t is root 21 over 5, find the value of each of the 4 remaining functions. So let's do it. Doesn't matter which one we do. Let's just do tangent first. So tangent is going to be 2/5 divided by, I'm going to write it like this instead of a fraction, divided by root 21 over 5. I'm going to do that keep, change, flip. If I'm dividing by a fraction, I'm multiplying by its reciprocal, right? So I got 2/5 times root 21 over, no, sorry, 5 over root 21. 5's cancel, and you get 2 over root 21. We're going to need to rationalize by multiplying by root 21 over root 21. And you end up with 2 root 21 over 21. Okay. All right, let's do cosecant next. This will be quicker. I'm not even going to do the whole dividing thing, right? Cosecant is the reciprocal of sine. So flip it. It's 5/2. Okay. Secant is the reciprocal of cosine. So flip it. You get 5 over root 21. This one we do need to rationalize, but that's it. So you end up with 5 root 21 over 21. Last one is cotangent. cotangent of t. And I'm just going to take what I got for tangent and flip that. So 21 over 2 root 21. I will need to rationalize that by multiplying by root 21. And you end up with 21 root 21 over 42. That you can then simplify, taking a 21 out, and you get root 21 over 2. Okay, so once you know, if you know sine and cosine, you can get the other 4 just by doing what you know. More identities. All right, so you got sine squared t plus cosine squared t equals 1. And then these are all corollaries of that. 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. Okay. So if you know what sine is, you can then find the value of cosine. You're going to use that first Pythagorean identity. If sine is 1/2, then 1/2 gets substituted in for sine. Sine squared t, if you know sine, then you just square the sine to get sine squared. So it's, notice how the 1/2 is just getting squared because that was squared there. That's it. So 1/2 squared is 1/4. So 1/4 plus cosine squared t is equal to 1. Subtract the 1/4 from both sides. You get cosine squared t is equal to 3/4. If you have cosine squared t and you want cosine of t, you just take a square root. So you end up with cosine of t is equal to square root of 3/4, which reduces to, well, square root of 4 is 2, so root 3 over 2. So we're going to do the exact same thing with this one. So you've got sine squared t plus cosine squared t is equal to 1. 3/5 is getting substituted in here. So now I've got 3/5 squared plus cosine squared t is equal to 1. 3/5 squared is 9/25 plus cosine squared t is equal to 1. I'm going to subtract 9/25 from both sides. So 25 minus 9 would be 16. Then I take a square root of both sides, and I get cosine of t is equal to square root of 16/25. Luckily, those are both square numbers, so you get 4/5. Same exact question, so why don't you pause, give it a try, and then I'll have it worked out and we can compare answers. So using the same identity, I substituted root 21 over 5 in for sine. I actually squared it and I got 21 over 25. I subtracted that 21/25 from both sides. I got 4/25. I then took a square root of both sides and I got 2/5. So cosine of t is equal to 2/5. All right, this is relating to what we talked about last week, or last lesson. Well, same thing, I guess. A function f is periodic if there exists a positive number p such that f of t plus p is equal to f of t, meaning all right, you've got your circle, you've got your spot here, right? Let's say that is f of t. This function is periodic, so sine or cosine or any of these are considered periodic if f of t, there exists something if you go all the way around, and I get f of t plus p. So I went all the way around, but these two are equal because they're at the same spot, right? The smallest positive number p for which f is periodic is called the period of f. So in this case, by going all the way around the circle, if we're just talking about the sine and cosine, the period would be 2 pi, right? Because you would take a full cycle to get around to that point. So sine and cosine, like t plus 2p is t plus 2 pi, is going to be the same thing for sine, and t plus 2 pi is going to be the same thing for cosine. So the sine and cosine functions are periodic functions and have period of 2 pi. Tangent and cotangent actually cycle through just by going halfway around the circle. Because since you're dividing, right, the thing that makes the sine and the cosine different on opposite sides of the circle is that one side's going to be positive, one side's going to be negative. But when you're talking about tangent or cotangent, since it's sine divided by cosine or cosine divided by sine, if one of them flips, if they both flip, right, one becomes positive and the other becomes negative, it's still going to be the same end result, right? So that's why it only takes halfway around the circle for tangent or cotangent to recycle. So their period is just pi. We didn't talk about it, but secant and cosecant, theirs are 2 pi because they're just the reciprocals of those. So find the value of each trigonometric function. So cotangent of 5 pi over 4 is the same thing as just cotangent of pi over 4, because pi over 4 plus pi is 5 pi over 4, and pi is the period, right? So if you know that cotangent of pi over 4 is 1, then you also know that cotangent of 5 pi over 4 is 1. So again, it's all relating back to that pi over 4. If we can figure out just a couple things, we have process to translate it to all over the circle, or more than one rotation around the circle. It even works going in negative directions. Cosine of negative 9 pi over 4. Remember that cosine is an even function, so that's the same thing as cosine of 9 pi over 4. Translating it to a positive is easier to think about. Cosine of pi over 4 plus 2 pi is the same thing as 9 pi over 4. So we're just going back to the original pi over 4 spot on the graph. Cosine of pi over 4 is root 2 over 2. So that means cosine of negative 9 pi over 4 is also root 2 over 2. So repetitive behaviors for sine, again, if you're adding 2 pi, and it could be 4 pi, or it could be 6 pi, or 8 pi, or whatever, it's just back to the same one. Oops, sorry. Same thing with cosine, and then tangent is just the pi. All right, so then anything else in between these special functions, and again, we'll look at 30 and 60 degrees more in a future lesson. We really focused on the 45 degree, which is the same thing as pi over 4. In this one, this is really just like the first step of translating stuff all over the unit circle. But anything that's not on the unit circle, anything in between is irrational. The only way to really do it is with a calculator. The important thing is be sure to set the mode to degrees or radians depending on the function that you are evaluating. So if you're given a radian, make sure you're in radian mode. If you're working with degrees, make sure your calculator is set to degrees. Otherwise, you will get a different answer. So let's look at these two. Sine of pi over 4, and it's equal to that. Well, how do I get that? All right. I'm just going to use this scientific calculator on Desmos. All right. Any scientific calculator, any graphing calculator is going to have this functionality. So it was sine of what, pi over 4. Okay. So you should have sine, cosine, and tangent buttons available to you. Depending on your calculator, you might also have the secant, cosecant, cotangent buttons as well. Certainly, if you have a TI graphing calculator, you would have those. It's not totally necessary, and I'll show you why in a second. But sine of pi over 4 sorry. Okay, that didn't really matter. But anyway, so sine of pi over 4 is considered that. But notice I'm in degree mode. I actually want to be in radian mode. We already talked about how sine of pi over 4 is equal to root 2 over 2, right? This is what I'm getting on the calculator. Guess what? Square root of 2 is roughly 1.41. So if I divide that by 2, I am getting that, right? So this is a decimal approximation of sine of pi over 4, okay? Again, notice how if I switch between radian and degree mode, I'm getting different answers. So that's an easy way to make a mistake on a test or a quiz or a homework or whatever. So make sure you're in the right mode. How do you know which mode to be in? Let's go back to the question. Sine of pi over 4, well, if you're given a radian, or if you're given something that's in terms of pi, it's definitely a radian. This one's a little less clear. Cosecant of 1.5. That looks like it could be a degree, but there's not a degree symbol. So that's really the key. And a lot of times a question may tell you like this is degrees or this is radians, but even if it doesn't, the way you tell is, does the number that you're taking the function of have a degree? Like if that was 1.5 degrees, it would have a degree. Okay. So this is not degrees, this is radians. So how do I get that answer in radians? Well, we just talked about there's not a cosecant button on my calculator, but how do I handle that? Let me clear this out. Okay, so how do I handle that? Cosecant, remember, is the reciprocal of sine. So all I have to do is just do 1 divided by sine of whatever it is. In this case, it was 1.5. And I'm getting that 1.0025 and so on, rounded. If you think about it, why does that answer make sense? Got your unit circle, right? All the way around is 2 pi, right? And right here is pi, right? What is pi? If you estimate it, it's like 3.14, right? So then what is pi over 2? It's going to be like 1 point, I don't know, 1.55 or something, right? Remember, sine is your y value. So that's right about where 1 is. So it makes sense that it's just about 1. Okay. I think that's about it for this lesson. A lot of different stuff went into this lesson. So, this is again just the kind of the building. We're still building, like we're taking another step here. So again, make sure you're asking questions. Make sure you're getting help with the practice. I'll have an exit ticket set up for you that you can try. We'll probably just do that together on Tuesday. These notes are pretty long, so I'm not going to have you also do an exit ticket. In conjunction with it, we'll do that together on Tuesday. All right, so let me know if you have questions.